Hi friends, I'm Hamsa. I'm studying in Sri Venkateshwara College of Engineering in Mechanical Department under Vishwesvaraya Technological University. Today I'm going to give a technical seminar on stereolithography resins for rapid prototyping. Overview of this technical seminar involves introduction, working principle, stereolithography process, stereolithography machine, rapid prototyping, types of SLA resins, advantages and disadvantages of SLA, and conclusion. Let's move on to the introduction. Stereolithography is defined as a additive manufacturing method and apparatus for making solid objects by successively printing thin layers of the ultraviolet curable material one top of the other. Stereolithography is a common rapid prototyping technology for producing parts with high accuracy and good surface finish. Stereolithography is a technique for layer-by-layer structure fabrication where a laser beam is focused to a free surface of a photosensitive liquid to induce polymerization of the liquid in that region and transform it to polymerized solid. Stereolithography is an additive manufacturing method. What is additive manufacturing? Additive manufacturing means addition of materials. Means the layer by layer formation is done to build a model. Additive manufacturing, the process of it is a process of layer by layer formation of material, and it prints the thin layers of the ultraviolet curable material one top of the other. Stereolithography is a common rapid prototyping technology. It is a common rapid prototyping technology for producing parts or models, which gives the good surface finish with high accuracy. Stereolithography is a technique which is layer by layer structure is formed. The layer by layer structure is fabricated to build a model. The laser beam is focused on the free surface of the photosensitive liquid. We use the photosensitive liquid as a material and we use a laser beam and the laser beam is focused on this photosensitive liquid to induce polymerization of this liquid and it converts to a polymerized solid. The photosensitive liquid is exposed to the laser beam which is in the form of liquid. Then after the focusing of laser beam, then it's converted to a solid form. That is polymerized solid form. Next is working principle. Stereolithography is a process which uses using a liquid UV, ultraviolet, curable photopolymer or resin and a UV laser to build parts a layer at a time. On each layer, the laser beam traces a path cross-section pattern on the surface of the liquid resin. Exposure to the UV laser light cues solidifies the pattern traced on the resin and others to hit the layer below. The stereolithography process uses a liquid UV curable photopolymer and it uses a UV laser beam to solidify the photosensitive liquid by layer at a time. On each layer, after each layer of the photosensitive liquid, this laser beam traces on this surface and it converts to a solid photopolymerized solid. Exposure to the UV laser light, it solidifies the pattern traced on the resin and others it to the layer below. Next is stereolithography process. This figure represents the stereolithography process. The stereolithography process consists of laser light, laser beam, scanner system, layers of solidified resin, liquid resin, platform and piston. Here you can observe the layers of solidified resin. Under these layers of solidified resin, you can observe this liquid resin. This liquid resin is exposed to this laser beam light. You can observe this laser beam light is this liquid resin is exposed to the laser beam, and that liquid resin is converted to a solid. This is a solidified resin. You can observe this. Next one is stereolithography machine. This is a stereolithography machine. The machine has four important parts: a tank with several gallons of liquid photopolymer, a perforated platform immersed in the tank, an ultraviolet laser, a computer that drives the laser and the platform. This machine consists of many four parts. That is the tank with liquid polymer. The main component of this rapid prototyping, the stereolithography process is liquid polymer is must required. So this machine consists of gallons of liquid photopolymer. This is a material and platform immersed in the tank. An ultraviolet laser is used. A computer that drives the laser and the platform. The machine can be run in the following modes, that is access mode, quick cast, solid weave. Next is stereolithography process. The first step of the stereolithography process is preparation of CAD model. Before the preparation of CAD model, the first step is the conceptualization of idea. The idea need to be selected. The model need to be selected. That model design is to be done by using a CAD model is to be done by using a softwares, CAD softwares like NX software and SolidEdge V19, CATIA software and all. By using this software, we have to prepare a CAD model which we want to be printed. The platform in the tank of photopolymer at the beginning of the print run. We have to adjust this photopolymer platform in the tank. The platform at the end of a print run shown here with several identical objects. The ultraviolet woven is used to cure completed object. This ultraviolet woven is which helps in solidifying the completed object. Next is procedure. The basic rapid prototyping process includes the following steps. Create a CAD model of the design, convert the CAD model to STL format, slice the STL file into thin cross-sectional layers, construct the model one layer atop another, clean and finishing the model. The basic rapid prototyping includes these 5 steps. I will take an example of a 3D printer. We have to create the CAD model of the design by using softwares, and that CAD model is converted to the STL format. Why STL format? STL format means stereolithography format. As we know that the 3D printer accepts only the STL format. So we have to convert the CAD model into STL format because the Ultimaker Cura software takes the files of only the STL format. The STL format is to be in .stl. This COD model is converted to the STL format. We slice the STL file into thin cross-sectional layers. The slicing is done by using the Ultimaker Cura software. And we have to construct the model one layer top another. Then clean and finishing the model. This involves the post-processing process. Means we have to remove the supporting structures and we have to remove the unwanted structures of the model. Photopolymerization is a process of reacting monomer molecules together. Means many monomers comprise to form a photopolymers. The chemical reactions forms three-dimensional network or polymer chains. This polymerization process consists of several network and 3D networks and polymer chains. When this process takes place under the influence of light rays, UV rays, the process is called photopolymerization. Next is resin. Resin is a hydrocarbon secretion of many plants, particularly coniferous trees. Resins consist primarily of secondary metabolites or compounds that apparently play no role in the primary physiology of a plant. It is valued for its chemical properties and associated uses such as the production of varnishes, adhesives, and food glazing agents. This resin is a hydrocarbon component we, um, we see in coniferous trees, especially in forest and all. Then it is valid for this its own chemical reaction and which is used in the production of varnishes, adhesive, and food glazing agents. Then it doesn't play any role in the primary physiology of a plant. Next is photocurable resins. The resin uses comprises of the following: at least one monomer or oligomer bonded directly or indirectly to a group of consisting of at least one silicon atom. This monomer or oligomer consists of at least only one silicon atom. Then vinyl monomer and cationic photoinitiator. Next is types of SLA resins used. Material, appearance, viscosity, and density. DSM SOMOS 10120. Its appearance is optically clear and its viscosity is 130 and its density is 1.12 gram per centimeter cube. Next material is DSM SOMOS 9120. Its appearance is transparent amber and its viscosity is 450 CPS and its density is gram per 1.13 gram per centimeter cube. Next material is Cibatul SL 5195. Its appearance is clear, its viscosity is 180 and its density is 1.16 gram per centimeter cube. Next one is advantages. Advantages is crisp and highly detailed. Speed of delivery usually 2 to 3 days. Tolerance with 0.005 inch saves money, time saving, test product, locates error, improves design, and rapid manufacturing. This rapid prototyping helps in saving money because the material used to build model of this rapid prototyping model is the material is not so expensive and it's very less expensive as compared to other materials. And to build a final model, we use many materials, like different materials and different composite materials, costly materials we use to build a final model. But to build a rapid prototyping model, no need to be costly materials and all. The material is cheap as compared to other materials. Then it is time saving. Why it is time saving? If we directly build a final model, if any mistake in this model, then we have to build again that model. So it is waste of time. Instead of doing that, we have to create that rapid prototyping model and we analyze the mistakes and that mistakes is clarified and corrected at the final model only. If we do like that, it saves time also and it saves money also. Then it is a test product. The many test has been done on the rapid prototyping model before doing on a final model. If we do test directly on the final model, if any mistake happens, then it's loss for us. Before testing on the final model, we have to test on the rapid prototyping model. So it acts as a test model or a test product. Then we can easily locate the error, or we can easily find out the error in rapid prototyping model. If we find any error in the rapid prototyping model, then that error is converted and that error is corrected in final model. If we see error in directly in final model, then it's very difficult for us to correct it at the end. So before finding error at the final model, uh, we find the error at the rapid prototyping model. Then we try to correct it. Then it improves the design of the model. Then it also enhances the rapid manufacturing. Next one is disadvantages. A key step in stereolithographic manufacturing is choosing an orientation for the model, that is the build direction. Model is composed of several layers, while slant edges and curves are involved. Good finishing is not obtained. Mechanical performance of the fabricated parts is limited by the materials used in the process. Next is conclusion. Stereolithography is now making transition from rapid prototyping to rapid manufacturing. Both photopolymer based as well as non-photopolymer based process are now used for short running manufacturing, resulting in faster and better manufactured components. More recently, attempts have been made at constructing mathematical models of the stereolithography process and designing algorithms that will automatically determine whether or not a proposed object may be constructed by using this process. In the near future, this could replace conventional manufacturing process in many fields. Stereolithography is now making transition from rapid prototyping to rapid manufacturing. So it makes transition from rapid prototyping to rapid manufacturing. Both photopolymer based as well as non-photopolymer based is used for short run manufacturing, which results in this photopolymer based as well as non-photopolymer based, which results in better and faster manufactured components. More recently, attempts have been made at constructing mathematical models of the stereolithography process and designing algorithms. The stereolithography process, to analyze this stereolithography process, the mathematical models is done, and designing algorithm are also be done to determine whether a proposed object may be constructed by using this process. In the near future, this could replace conventional manufacturing process in many fields. This rapid prototyping is used in many fields like medical purpose, industrial purpose. In medical purpose, this rapid prototyping model plays a very important role in medical purpose, like in dentistry and all, like anatomy, dentistry, to build a model to analyze the model. And artificial bones has been done by using this rapid prototyping, and artificial teeth and orthodontist is treated by using this additive manufacturing only. Only it has many applications of this rapid prototyping, and this rapid prototyping are also used in project thesis and projects and all, and in research field also it has been used, and it makes a transition from rapid prototyping to rapid manufacturing. Thank you.